a weld inspector at a shipyard. He knows from keeping track of good and substandard welds that for the afternoon shift, 5% of all welds done will be substandard. If Smith checks 300 of the 7,500 welds completed that shift, what is the probability that he will find more than 25 substandard welds? So let's try to answer this question. So here you see that the probability of substandard welds would be 5%. Right, so this is a 5% here. So that's p, lowercase p, so p is equal to 5%, and which is equal to 0.05. And in this shift, like so he checks 300 of welds of the total 7,500 that were completed. So population size uppercase n, that is 7,500, and then sample that he is checking its size is 300, so lowercase n, so that is equal to 300, and we have to answer that probability that he will find more than 25 substandard welds. So probability of, like say, this sample proportion is at the more than 25 out of 300, so this is we have to find. So probability that the sample proportion p hat is greater than 25 out of these 300, which is the same as probability that p hat is greater than 1 by 12. So this is the probability that we have to find. So before we answer this question, so we have to first look for this the sampling distribution for p hat. So this model would work if these conditions are satisfied. You see here this number 1, that the sample size should be less than 5% of the population size. This is one thing we have to check. And then second thing we have to check is this one, right? So np times 1 minus p is greater or equal to 10. And then if this happens, so then we will know that this is the standard deviation of the p hat, and mean of the p hat would be the same as p. So let's do that. So first, think that the n is less or equal to 5% of the population size, right? First this one. So n we have this 300, and we're going to see that okay, this is true or not, right? So 5% is 0.05 of 7,500, and this would turn out to be 375. So we know that this is greater or equal to 300, so it's true. So this first condition is true. Second condition again was this np times 1 minus p. This should be greater or equal to 10. So let's check that. np times 1 minus p. So n is 300 and p is 0.05, and 1 minus p would be 1 minus 14.25, and which is definitely greater than 10. So this condition that np times 1 minus p is also greater or equal to 10, so it's satisfied, right? So second condition. So if these conditions are satisfied, so this model would work, and then we can see that so mu p hat, so that's equal to p, and p is 5%, 0.05, and then sigma p hat, so that's equal to again from this equation, right? So square root of p times 1 minus p by n. P is 0.05 times 1 minus 0.5 and divided by square root of 300, and that's equal to 0.012583. So now with this, the mean of this p hat and then standard deviation of p hat, with this having this sampling distribution for the proportion, so we can answer this question, this part here. And with these conditions, these are satisfied. So it means that so we can apply the normal distribution to answer this question for p hat. So we make this normal curve for p hat. So this is mean here. So mu p hat 0.05, and because we have to tell that this probability of p hat, right, is greater or equal to 112, so that's equal to 0.08 approximately at C3, so that would be somewhere here. So that is 1.08 like this. And to find that the probability is greater than 112 here, so it means that you have to find this area. So to figure this out, so we have to first find z value corresponding to this p hat. So that z value would be p hat minus mu p hat divided by sigma p hat. So p hat is like 1 by 12 minus mu p hat is 0.05. The whole thing divided by sigma p hat, so that's this value here. 0.012583, and this will be equal to 2.65. So this z value 2.65, this is corresponding to this value, so let me write it here, 2.65. And now we would be looking into standard normal distribution table, so that when z is equal to 2.65, so what would be the area? So remember that area from the standard normal distribution would be on the left side of this line. Okay, so first find this out. Okay, so what we have here on the left side, our z value was 2.65, so this is standard normal distribution table. So 2.65, and you can see here, so 2.6 this z value, and then next digit is 5, so this would be 0 here. So in this line, so this is 0, then 1, next digit 2, 3, 4, 5. So basically this is the value 0.9960. So 0.9960. So this is the area on the left. Then this area on this side would be 1 minus area on the left, so 0.9960, which is equal to 0.0040. that's your answer, and we would write it here that the probability that the proportion would be greater than this 25 out of 300, right? So that would be the same as that z is greater than 2.65, so which is equal to 0.0040.